Let us solve example 1 using the force method, also known as the consistent deformation method. Our objective is to determine the reaction at the roller support B. The beam is fixed at A, supported by a roller at B, and carries a 50 kilonewton concentrated load at the midpoint C over a span of 12 meters. Since the beam has one more unknown reaction than the available equilibrium equations, it is first-degree statically indeterminate. To solve it, we choose the vertical reaction at B, denoted by By, as the redundant force. Removing support B converts the beam into a cantilever, fixed at A, called the primary structure. Using the principle of superposition, the actual beam is represented as two simpler systems. The first is the cantilever carrying the 50 kilonewton load, producing a downward displacement at B. The second is the cantilever subjected to the redundant force By, producing an upward displacement at B. Because support B cannot move vertically in the actual structure, the net displacement at B must be 0. This gives the compatibility equation. 0 equals minus delta B plus By FBB. Using standard cantilever formulas, we obtain delta B equals 9,000 over EI and FBB equals 576 over EI. Substituting these values and solving gives By equals 15.6 kilonewtons upward. Applying equilibrium equations, we find AY equals 34.4 kilonewtons upward and MA equals 112 kilonewton meters. These values are then used to draw the bending moment diagram. Thus, the required roller reaction is By equals 15.6 kilonewtons upward. Thank you for watching. If you found this example helpful, please like the video, subscribe to the channel, and press the notification bell so you never miss upcoming lessons on structural analysis, force method, and other civil engineering topics. See you in the next example.